In this video, I'll demonstrate how to create a disintegration effect and a growth effect using some of the concepts I showed from previous videos. For these two effects, you need to know how to use Foreach loops and how to use the SOP Solver. If you need a refresher in either of these two, please check out these videos. Links in the description. I'm going to start off with the geometry node. Then I'm going to make a cube. Now this is the cube that I'm going to disintegrate. Next, I'm going to put a solver down. So this is my SOP solver. So I'm going to be using this SOP solver, and I'm going to eat away at the cube slowly, frame by frame. So let's go inside to the SOP solver. Now, I'm not going to be using these inputs. The only input I need is the previous frame, which is right now is the cube. So let's scatter some points onto the cube. Now this is way too many points. I'm just gonna use 10. Now I'm gonna create a spear and change the spear to polygon. Now this is the spear I'm gonna be using to eat away at the cube. So I'm gonna copy the spear to these points. So I need a copy to points node. So the spear is obviously, all the spears are obviously too big. So I'm going to make this spear a lot smaller. Or actually, I can make the cube larger. It doesn't have to necessarily be the spear being smaller. You can make the cube a lot bigger. So I'm going to make the cube 10 times bigger. The reason why I choose to make this cube bigger instead of making the spear smaller is because I'm going to be changing this to a volume later on, and it's much easier for the voxel size, because 0.1 voxel size is the default voxel size for most of the volume settings. So it just works out conveniently in the numbers, in the default numbers. I mean, you can change this spear size to be smaller instead of making the cube larger. Now I'm going to be iterating through all these spears, all these 10 spears, and eating away at this cube one spear at a time. So I'll need a Foreach loop. For each connected piece is what I'm looking for, because I want to iterate through each spear. However, there isn't a spot in the Foreach loop where I can plug the cube. I need one more input. So you can always, if you need another input for for each block, you can always put down a block begin node. Now once you put this down, it'll provide another input for each loop. Now it's not part of the orange block right now, so it's not part of the Foreach block, Foreach loop. In the block begin node that we just put down, it's asking for a block path. Basically, it's asking us what for each loop will this node be part of. And that's this for each block. So I'm going to click and drag this for each end node, and I'm going to click and drag it into the block path. So now this block begin node is part of the for each loop. Now we have a place to put hook up the cube as part of the input. Now this for each end block, it's by pieces of points, that's correct. The gather method merge each iteration. Now I don't want 10 cubes, so I'm gonna choose feedback each iteration. And default block path, I'm gonna be choosing this block begin node. And I'll explain why in just a sec, but for now I'm just gonna choose that. Okay, so I put the render flag on the for each end. It's iterating through all 10 pieces. We see piece 9, that's because it's 0 index based. So it's iterating through all the pieces, all the spears, one at a time. So we got that. Now we need a way to subtract the spear from the cube. Now there's something called a VDB combine. This does addition, subtraction among volumes. And it does it really quickly. So this is perfect for what we have here. The only problem is VDB combine requires a volume. We have a polygon cube here. Okay, let me just reset this. We have polygon cube here, and we got polygon spheres. So we need to convert this into VDB. I need a VDB from polygons. I'm gonna hook this up to the cube first. Now I know that I'm gonna be using the VDB combine, and I'm gonna be using this to do the subtracting the spheres from the cube and slowly eating away at it. And it needs to be done multiple times, once for every, subtracting every sphere one at a time from the cube. So this VDB combine will be operated multiple times. So it needs to be inside the Foreach loop. Now, what am I subtracting? I'm subtracting the cube. So this is the input for the cube. The block begin node is the input for the cube. I'm going to hook this up to the left-hand side, and I'm going to hook the other input to the sphere. Now, this will, for each begin one node is iterating through each sphere. So every single time it iterates, it's giving me one sphere polygon though. So I need to convert it into a VDB as well. So I drop down a VDB from polygons. Okay, let's hook this one up. Since this right here converts the sphere into a VDB, into a volume. Now we can hook this sphere into the right input of the VDB combine, because we have two volumes, and we can do an operation on the both volumes. What kind of operation we want? We want to subtract it. So we want an SDF difference. Now, I'm not seeing the difference. All I see is the sphere. That's because over here, for the block begin node, we have fetch feedback. The problem is we have this for each begin node hooked directly to the for each end node. So we're outputting the sphere right away. So that's not what we want. We want to output the cube, the disintegrating cube. So this is what we're outputting. So I'm going to hook this up here. Put the render flag here. Okay, now I'm starting to see a cube that has holes in it. We're starting to get somewhere. So that is one of the reasons why I need the default block path to be this node, because that's what I'm outputting. Now I'm going to drag this up. I'm going to add a VDB convert. Now why would I need a VDB convert? Because it's a volume right now. Now I can render a volume. However, I want to render a VDB I want to render a polygon. So I'm going to convert this volume into a polygon. This looks like it's working. However, I want to smooth it out a bit. It's a little too, because I want the disintegration to have smooth, to sort of melt down. So I'm going to put down a VDB smooth. Now this VDB smooth needs to be for the VDB convert, because right here, this is a polygon. Over here, right at the end of the for each end loop, it is a volume. So that's where I want to hook it up to. So it smooths it down a little bit. So you can see these edges are being smoothed down. They're not sharp. They're not sharp like this. They're a lot smoother. Imagine this smoothing happening over and over and over and over. It will look like it's melting down inwards. So I'm going to play a few frames to show you what it looks like so far. Put a null down, out, render flag. So I'm going to come back up, select the SOP Solver, reset. I'm just going to play a few frames. So let's see what it looks like. Frame 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's not too bad for the first 15 frames. However, I want to change this a little bit more. So let's reset this. Reset the timeline. Go back in. This is our node network. I want to change the sphere. I want to change the shape of it. I want to put a bit of random noise around the surface, like a mountain sop. Put an empty node here so it doesn't get in the way. Now this sphere, drag it up here. Now I'm going to put a mountain sop. So this is what the sphere looks like right now. With the mountain sop, it's a little bit changed, which is cool, but I want to change this a little bit more. So I'm going to lower the scale of it. I think the resolution is too low for the sphere. So select the sphere. I'm going to increase the frequency by 4. So that doubles the resolution of the sphere. Select the mountain sop. Let's lower the scale down a little bit more. It looks to something that looks interesting. Lower the height maybe. Increase the height. Element size, decrease it maybe. or increase it. Okay, something like that. Now, let's see what it looks like. That's cool. However, the orientation of all these spheres with noises, these spheres, the orientation is all the same. So I want to make it more interesting. Copy stamp. What this node does, it does the exact same thing as the copy to points node, except you can stamp inputs on every copy iteration. So copy to points is sort of like doing iteration. It does a copy every single time. A copy stamp will do the same thing. It'll copy and it'll attach a variable every single time it copies the node. So we can attach a random variable to every iteration, to every copy iteration, and then randomly rotate these spheres. So I'm going to put this down. I'm going to use the same input nodes as the copy to points node and plug it into the copy stamp node. Select this. It has a copy stamp attribute. Now choose stamp. Let's create a variable. Random orient. So what is the value? Now we need to use some of the Houdini's expression functions. The Houdini has a rand function, but we need a seed value. And this seed value needs to be different every time to produce a random number every time. So if the seed is the same number every single time, you're going to get the same random number. So it's not very random at that point. Now, how can I get a different number every single time? The point number will be different. So I'm going to use ptnum. This will generate a random number every single time. Now, this random Houdini expression returns a random number ranging from 0 to 1. That's not going to be very useful because I want to rotate it. And rotation is from 0 to 360 degrees. So we can do something here. We can put down a fit. And what this does, it'll fit our random number from the 0 to 1 range into another range that we can specify. Now fit, so it requires a number which will be our random number. The range of our random number, so what's the original range of this random number? It ranges from 0 to 1. So we put 0, 1. Now that's the original range of the random number, of our input number. But what do we want to output now? We want to get a degree back that ranges from 0 to 360. So I'm going to put 0 and 360. So what this fit function will do, it will return a number that ranges from 0 to 360. So we get 230 right now. Now, how do we use this? Well, I need a transform node because I need to rotate this sphere. So where do we want to rotate? Let's just rotate the y-axis. So how do I access that random orient variable that I created in the copy stamp? There's a stamp function. In the Houdini expressions, there's a stamp function that we can get. Now, there's 3 inputs that it requires. First input is where is this stamp function? Where is the copy stamp node? It's asking for the copy stamp node, and it's asking it in a string format. So it's one level above the transform node. So I'm going to put dot dot slash, and Houdini starts the list. This autocomplete box starts to come up, and it asks you, this is your available choices. Well, the name of that copy stamp node is copy1. So I'm going to start typing C. Oh, there it is. I see it right here. This is it. Then you just select it, enter. Now I'm going to put a comma, and it's asking for another string. Now this is the name of the variable that we created. So it's random orient. That was the name that I created. Now the last input is asking for, if I can't find this variable, do you have a default value for me? Sure, I'll just put 0. So no change. So this 0 value is only used if something goes wrong. And we'll know if something goes wrong when they all face the same direction, which is exactly what they're doing right now. So they're all facing the same direction. So something is obviously wrong. It's not randomizing the rotation I'm doing on the y-axis. So what are we doing wrong here? Select the copy stamp node, and you can see here that there's a stamp input under the stamp tab. So let's check this. Okay, now they're stamping. Now you see them oriented differently. Now we can replace this copy to points. So I'm going to drag the output of this copy stamp and into the connectivity node. And we don't even need this copy to points. I can just delete it. Okay, I'm going to put the render flag back to the out. Now I'm going to go back up, reset the sim, and I'm going to cook a few frames again. Okay, let's watch this through. Frame 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's not too bad. However, I think this is disintegrating too fast. I'm going to try making the cube a little bit larger, because I think it's disintegrating too fast. Like, this is only 16 frames, and it's eaten it like a quarter of it. I'm going to make it a little larger, 12 maybe. And I'm going to run this through. Now, before I run it through, I'm going to attach a file cache here. Since every single frame is different, the cube is actually deforming for every single frame. The polygon count is different for every single frame. So it's a good idea to put down a file cache. It's more efficient that way. I'm gonna remove this hip name though, only because I have multiple versions for this tutorial. You can keep that. You can keep the hip name in there. And I'm gonna click save to disk and just let it cook through all 240 frames. Okay, it just finished cooking. So I'm just gonna play it. I'm gonna turn on real-time playback so it doesn't play too fast. Disintegrated, so it completely disintegrated there was like nothing left after 120 frames and nothing left. So I'm gonna make the box a little bit bigger. You can leave it at that if like I just want a longer animation. So I'm gonna make it like 16 then. I'm gonna try it again. So it just finished cooking. So I'm just gonna play this. So now it lasts a lot longer. However, I kind of liked how it looked before though. So I'm gonna lower this a bit. Maybe 14. You can keep adjusting it like this. So I'm just gonna leave it like I'm gonna cook it one more time, but I'm gonna leave it as is. So it just finished cooking. So let's see what it looks like. So that's not too bad. It runs it disappears on frame 182 is the last sign of its existence, and 183 it's completely gone. So that's not too bad. I'm just gonna leave it as it is. Now I want to do the opposite of the disintegration. I'm gonna do a growth scene. So instead of having the spears eating away at the cube, it's gonna grow and keep adding more spears onto the cube. Now the process is very similar to the disintegration one. So I'm gonna copy this and paste it here. I'm gonna rename this growth. I'm gonna turn off this render flag just for now. Come in here and I'm not gonna file cache it yet, so I'll just come up here, reset. Let's go inside. The only distinction we have is this is the main part that we have to change. Instead of taking the SDF difference in the VDB combine, I'm gonna do a SDF union. So because I'm combining the spears and appending more spears to the cube instead of eating away. So I'm going to change this to SDF union. Come back up, reset the sim, and I'm going to see what it looks like for a few frames. Okay, let's see what it looks like. Let's go back to frame 1, 2, 3, 4, 5. Change this angle a bit. Not bad. Okay, we're getting somewhere. Now it's growing all over the place. This could be something that you want. You might be happy with this. Or we can do something even more. I might just want it to grow on top of the growth. So instead of always randomly scattering points, what this is doing, it's taking the entire cube along with the appended spears and scatters random points on top of the whole result. However, I only want to concentrate the growth in certain areas, which should result in longer strains of spears that are going to append on top of each other. I only want to scatter growth points on top of what is already growing and not from the original cube. The original cube may work for the first frame, But after that, I want to scatter points only on the growth. And as a result, we should have longer strains because the scatter points are targeting the strings of spears that is growing out of there. We're only scattering more strings on top of that. So we need a way to distinguish, to identify the growth points in the original cube from the previous result. Now, I can do that very easily with by creating a group. Now, group create. Now, what would I put in this group? What points would I put in this group? I need to group the original cube, like the resulting cube, the resulting cube. So let's put this down. So it's gonna be at the end. I want to group this. So I'm gonna attach this to the left input. Yeah, this group will be called growth points. And I'm gonna change it to points. And instead of using base, because this is gonna put everything in it, I'm gonna use bounding regions and enable this. Okay, before that, what are the points that I want to put into this group? Well, I have them already. This is my growth. This is exactly my growth. These here is my growth. This is defining the growth in this frame. That is actually the growth. So I can attach this, the result of this, to the right side of this group input. This is the bounding object. What this will do is that all the spears, all the 10 spears being scattered all over this, will become bounding regions to put into this group. Points from this left input, I want the bounding objects that overlap these 10 spears. And anything inside these 10 spears from this resulting growth cube, I want to put into this growth points group that I'm creating. So basically everything that the right input is overlapping with the left input will be put into this group. And inside here, I want keep in bounding regions. Enable this. Select for bounding type, select bounding objects. Now that selecting this will tell this node to use this input that we have put on the right hand side. Now I'm gonna feed this output. So now we have the growth point. The highlighted orange points are inside the growth points group. Now we do have a slight problem. At the beginning here, this scatter point is still scattering off everything. We're not using this group up here to scatter growth. It's not being used at all. So it's just scattering everywhere. So we need a way to isolate the growth points and only scatter on top of the growth points and not the whole geometry. So let's put down a blast. This will delete everything else that is not part of the group, which will isolate the growth points. Only going to be using it to define the growth. So we want it here. Now click this, the growth points is not available to be selected. Now, why is that? That is because if I come back up here, this box, we start off with this box. This box doesn't have any group in it. It has no growth point group in it. So let's add a group. Now at the beginning, we want to scatter points all over the cube. So the whole cube is available for growth point. So this is the only exception for the first frame. So the whole cube is growth points. So this is okay. This will put the whole thing here, all of it. Well, the cube doesn't have much points though. Okay. Now let's come back here. Let's go here, reset. This blast. Let's select this. Now we have growth points available. Let's select this. Delete non-selected. So this will isolate only the growth points. You need to know that this blast works for this growth point. So over here, the original cube here and down here, we're not deleting anything. We're taking the whole result as is. So that's important. Now let me put the render flag back down here. Go back up, reset this, and I'm gonna do a few frames. Now it's starting to look like it's doing what we want because most of the growth is concentrated on one point, which is the previous growth. So the growth is appending on top of the growth, which is nice. So what is grown at the beginning, those points are kickstarting it to grow even more and concentrating only on those points. So I'm gonna reset this and I'm gonna cook this through the whole 240 and see what it looks like. Now I just finished cooking, so I'm just gonna load this. I'm just gonna change the angle a little bit. I'm gonna change the angle again because it's growing on the other side. I'm gonna change the camera angle one more time. Disconnected in the middle. The disconnection happens because I put down a VDB smoothing. It's growing while it's melting down, which I kind of like that look. But if you don't like that look, you can take those nodes away. And that's these nodes, these two nodes. Sorry, this node, the VDB smoothing node. If you take that away, it won't smooth down as much. Or you can lower down the iterations, the amount of smoothing iterations it's doing, and it won't melt down as much to a point where it disconnects. We have a disconnection happening here too, but I kind of like this look, so I'm just gonna keep it like that. I hope this video will make you realize the power of Foreach loops and the SOP solver. Both nodes are very powerful in their own features, and when combined, it's even possible to create really nice effects with a rather simple setup. Try coming up with different operations you can use inside the Foreach loop instead of what I did with the VDB combine operation, which is what I used. Try replacing it with different operations and experiment around. Or you can append different operations after the VDB combine and make it more visually interesting. Thank you for watching and sticking to the end.